Hey, what's going on, everybody? It's Derek here, and today we're going to be looking at a good chunk of one of the Solutions Architect Associate practice quizzes. If you want to see the whole thing and take it yourself, then I have links in the description below on where you can find that. Of course, as you can see here, with those links, you'll get 2 practice quizzes to help you adequately prepare for this exam and feel confident going into it, because it's not necessarily the easiest one. It took me 2 tries actually to pass this exam. I came close. I was about 50 points shy the first time, but whatever. So it's good to just take practice quizzes, and the objective here today is going to be to walk you through how you should be approaching these questions, how you should be picking out key details, what you should be looking for. And once we submit it at the end, we'll also go through some of the documentation that's going to be linked for right and wrong answers, so that you can reference that and just become more well versed and understand why your answers were right or wrong one way or the other. Okay, so let's go ahead and get into it, starting with question number 1. So we have a healthcare organization that is migrating its on-premise data center to AWS, and they need to ensure that they remain compliant with HIPAA regulations. It's a big deal with healthcare. So as an AWS Solutions Architect, which AWS service should you recommend for the secure processing, transmission, and storage of protected health information? So right away, we are going to be taking note of the fact that it says processing, transmission, and storage. Okay, so we're looking to do a few things here. Amazon S3 with default settings. I don't believe that's going to be correct, because with HIPAA there's going to be specific regulations and requirements to protect, like it says, health information. So the default settings probably wouldn't be the best bet there. CloudFront is going to be a content delivery service, so that's definitely not going to be an option here, because it doesn't necessarily store anything. AWS Lambda with a VPC. Again, Lambda is just a serverless compute service, but that's not going to have anything to do with storage, and VPC obviously not related to storage either. So that leaves us with option D, which is S3 with encryption and logging enabled, which makes sense to me because encryption obviously is going to keep things nice and secure, and then logging will allow you to see what kind of access is being given to your information, and if there's any changes or any of that nature. So I'm going to go with option D here. Okay. Moving on, you are a solutions architect for a media company that uses a cluster of EC2 instances to perform video processing tasks. These tasks require shared access to large video files that need to be retained for a long period. The CTO wants a scalable and high-performing shared file storage solution that can be concurrently accessed by all EC2 instances. What service would you recommend? So right off the bat, it says that we need a shared file storage solution, okay? File storage being the key words there, that can be concurrently accessed by all EC2 instances, all right? So looking at these answers, we've got Amazon S3, which is more object type storage. It's kind of a broad storage service. It's not necessarily meant for shared files in particular, so I don't think it's going to be that. EBS, Elastic Block Store, that's just going to be block storage. It's designed to be attached to EC2 instances, but again, it's not necessarily used for file storage. Glacier is going to be an archive solution, archive storage solution rather, that's kind of part of S3. But it's not designed to be accessed frequently, and this says that it needs to be accessed by EC2 instances, so I'm pretty sure we can rule that out. And then finally, we've got EFS. So we've got our elastic file storage here. So that is going to be what I'm going to go with, because you can, in fact, use EFS and mount it so that, mount it to different mount points rather, so that it can be accessed by multiple EC2 instances concurrently, so at the same time. So I'm going to say EFS and move on. You are the solutions architect for a medium-sized business that has been gradually shifting its workloads to AWS. The CTO wants to improve the security posture of the company and wants you to implement best practices to secure their workloads. Which of the following should be your primary action? So right off the bat, we're thinking security, because we want to consider best practices for securing workloads. So let's see, so ensure all instances are launched in public subnets to ensure high availability. Well, that's not very secure if you've got everything in public subnets, so I can rule that one out right away. Use a single AWS account for all departments to simplify management and reduce costs. Not very secure again, because everything's kind of linked to one account. If this account's compromised, then your entire business is kind of screwed, so probably going to rule that one out. Hardcode AWS access keys and secret access keys in the app for persistent AWS connectivity. That is very well against AWS security best practices. You do not want to hardcode anything, access keys or credentials related in your application. You want to use something like KMS or Secrets Manager. So that leaves us again with option D, which seems to be the winner here so far. Apply the principle of least privilege to IAM roles and enforce MFA. That's perfect. So the principle of least privilege, you only have enough permissions to do your job and nothing else. And of course, MFA, right? When you log in, you have to verify like a code sent to your phone, either via text or email, something like that is pretty common. So I'm gonna go with that. And let's go ahead and move on. So your company has decided to migrate a massive data set from their on-premise data center to the AWS cloud. And then you as a solutions architect have been tasked with ensuring that the data is migrated securely and efficiently without significant downtime. The data volume is in the petabytes range, so we've got a lot of data here. And your company's internet connection is not exceptionally fast. So which service would be the best possible solution for this migration? So if we're talking petabytes of data and a relatively slow internet connection, then that tells me we're probably not going to want to transfer this over the internet. So let's see what's going on here. So AWS Data Sync. That's not going to be for migrating data, so I'm going to rule that out. DMS, Database Migration Service. It doesn't really say in the question anywhere that we're working with databases, so let's rule that out for now. AWS Snowball, that actually looks really good. So again, that's where AWS will send you a physical device to your on-premise data center. You upload your data to that device, so it's much faster than trying to do it over the internet, and then you just send that device back and then AWS uploads it for you. So I'm going to go ahead and select this one. But to just finish up with these answers, S3 transfer acceleration. So again, that's going to go over the internet. Probably not the best bet if we've got slower internet speed, and this really just transfers things kind of between regions, different locations. But it's not necessarily specifically meant for migrating from on-prem to the cloud. But that's exactly what Snowball is for. So I'm just going to go ahead and commit to that. All right, your organization is undergoing a database migration from MySQL to PostgreSQL. As part of this migration, you set up a standby RDS instance to hold business-critical data in case something goes wrong and you need a quick restore of this data. You provision a general-purpose SSD storage database with 1 TB of storage, but you disable it upon creation so that nobody can connect to it, use it, and incur the subsequent charges. So you've got the standby database that's provisioned but not being used. Your migration goes as planned over the course of 2 weeks, and you do not have to start up this standby RDS instance. But on your next bill, you notice an abnormally large amount that was spent on RDS. So what could be the cause of this? So let's see, although you did not use the instance, you still paid for the backup for any data on your instance. That's not going to be the case because with RDS, backup is actually free up to the provisioned amount of storage you have, which is pretty nice. Although you did not use the instance, you still paid for the total provisioned storage. That makes sense to me. That's happened to me before, actually. You provision a database and then you don't use it, but you just forget about it, and then all of a sudden you're paying for it. The price to transfer data into RDS was greater than anticipated. This is also free, transferring data in. And you consumed more IOs than anticipated when transferring data into your instance. I don't believe that is also something that you pay for because, again, you're transferring data in. So I'm going to go with answer B here. All right. You've finally gotten away from answer D. All right, moving on. Your organization operates with multiple AWS accounts managed under AWS organizations. Okay. The CFO has raised concerns about runaway costs and wants to ensure that only a limited number of departments can launch EC2 instances of the larger sizes, such as M5.8x large, it's a huge instance. As a solutions architect, which of the following is the most appropriate action to take? Let's see, so remove all EC2 permissions from IAM users in all departments except those who need to launch large instances. Probably don't want to do that because if you remove all EC2 permissions, then they can't do anything with EC2, and all you want them to do is not be able to launch larger instances, so I'm going to rule that one out. Implement service control policies that deny the ability to launch large EC2 instances except for the departments that require it. That's definitely promising because, again, we are in an organization here, and SCPs kind of set the guardrails and say what is and is not possible. So that seems okay. Contact AWS support to restrict the instance types available to your organization. That's not in the scope of AWS support. And then regularly monitor CloudTrail logs and alert the relevant department when large instances are launched. That could be helpful for seeing when something was launched, but it's not necessarily going to restrict it in the first place. You're still going to theoretically be able to launch them, and then you'll have to pay for them. So I'm going to go ahead and go with B. Implement SCPs. SCPs are great. And again, they're exclusive to organizations, and they set guardrails on what is possible and not possible to do. Okay. All right, you are a solutions architect for a company that hosts its application on EC2 instances within a private subnet in a VPC. The application needs to access data in an S3 bucket, but the company's security policy states that no traffic should traverse the public internet. Okay. What is the most suitable approach to meet this requirement? All right, so let's actually read that again. So application on EC2, private subnet. We need to access S3, but we shouldn't go over the public internet, and the most suitable approach. So internet gateway to allow EC2 instances access to the bucket. Obviously, that's not going to be correct because we don't want to traverse the public internet. So let's rule that one out. Use a NAT gateway to allow the EC2 instances to access the S3 bucket. I'm not thinking that's going to be correct because a NAT gateway, again, is designed to get you from a private subnet out to the public internet. And again, we don't really want to do that. Use a VPN connection to the S3 bucket. Yeah, not necessarily. So VPN connections are meant more for network connectivity and not necessarily connecting to like a bucket specifically. And then use a VPC endpoint for S3. That actually sounds good. We could use a gateway endpoint which again, those are meant for S3 and DynamoDB exclusively. So I'm going to go ahead and actually select that and move on. So your company runs a high traffic e-commerce website on AWS. During peak traffic periods, database read requests sometimes exceed capacity, leading to slow response times. The company's customer satisfaction is highly dependent on site performance, which makes this a critical issue. As a solution, you are considering implementing read replicas to distribute the read traffic. Which database service would best support this scenario? So essentially, we need to just think about what service is going to allow you to implement read replicas. Amazon Aurora definitely does do that. Okay, it's a relational database service. It's AWS's own kind of fork of PostgreSQL and MySQL, if I remember right. DynamoDB is not necessarily meant for read replicas. It's kind of a NoSQL based service. Redshift is a analytics kind of data warehousing solution. Again, it's not going to be meant for read replicas. And then DocumentDB is kind of a document database, which again has nothing to do with read replicas in this case. So I am going to go with Aurora. All right, you are a solutions architect at a data analytics firm. The firm processes large amounts of data using a multi-stage pipeline of AWS Lambda functions, each performing a distinct step in the overall process. The CTO has expressed concerns about the reliability of this pipeline, as failure of any step currently results in the need to restart the entire pipeline. Which service should you introduce to the architecture to improve its resilience and orchestration? All right, so processing large amounts of data using Lambda functions, and we need to improve resilience and orchestration. All right, so CloudTrail. CloudTrail is a kind of logging service for API calls. It's not necessarily going to help us improve resilience and orchestration, of a pipeline. So I'm going to rule that out. AWS Data Pipeline. That I'm a little fuzzy on what that service actually does, but that could be an option. Let's look at the other ones. Step functions are definitely meant to make workflow orchestration more user-friendly, so that could be an option out there. It also allows you to kind of organize how your architecture and your pipeline kind of perform and what order of operations are taken. And CloudWatch, similar to CloudTrail, this is just kind of a logging and monitoring service. It's not really going to help us, improve the reliability and resiliency of a pipeline. So I'm going to go with step functions specifically because it talks about orchestration, and I know that step functions are really meant to help workflow orchestration. So yeah, let's go ahead and go with step functions there. Okay. Next, we'll just do a couple more here, then we'll go ahead and submit. Your company has an application that receives a large amount of web traffic which it needs to handle without any performance issues. The app architecture consists of a web tier and processing tier. Okay? You have noticed that when the traffic spikes, the processing tier becomes a bottleneck, causing performance issues. As the AWS Solutions Architect, what would be your recommended solution for decoupling the app tiers and managing the traffic spikes more efficiently? All right, so we're looking to decouple some of these application tiers from our processing tier because the processing tier is causing problems. So let's see, increase the size of the instances and the processing tier to handle load. That could help, but that's not really relevant to decoupling an application. So let's keep that one in mind, but I'm not convinced that that's the answer. Use AWS Lambda to process the requests in the processing tier. I don't think that would help, because if you have a lot of requests, it doesn't matter if it's Lambda or like dedicated servers, you know, it can still get bogged down. And additionally, Lambda has like a runtime limit. So if you have something that runs over a specific time limit, then Lambda will, you know, time out and fail, and that's obviously not what you want. Use an SQS between the web tier and the processing tier. That definitely makes sense. SQS is specifically for decoupling applications. So I'm pretty convinced that's the answer. Let's look at this last one though. Implement an API gateway between the web tier and processing tier. That's not really going to help manage load. That's really just to kind of manage and secure your APIs, which again doesn't really help in regards to like decoupling an application due to performance issues. So I'm going to go with and use an SQS queue and sit it between the web and the processing tier. That makes sense to me. All right, let's get this last one here. So as a solutions architect at a multinational corporation, you are managing multiple AWS accounts under AWS organizations for different departments. The IT security department has asked you to ensure that no department, including the root user in those accounts, can modify IAM policies in their respective AWS accounts. What approach should you take to meet this requirement? So since we're working with multiple accounts in an organization, and we're talking restricting policy permissions basically, and all accounts, right off the bat I'm thinking an SCP, but let's look at these answers here. So apply an IAM policy denying all IAM actions to each user in every account. That's a horrible idea, because at that point nobody would be able to manage IAM, which is not ideal, so let's rule that one out. Apply a service control policy at the root of your organization that denies IAM policy modifications. That makes sense because, again, if we want to include the root account, then we want to apply that SCP at the very top of our organizational hierarchy, and then that would trickle down to every organizational unit in our organization. And again, this doesn't completely restrict IAM like the first option does. It only denies IAM policy modifications, which essentially is what we want. Let's look at the other two here. So use AWS config to continuously monitor and revert any changes to IAM policies. Config's not really going to be able to revert changes, so I am going to rule that one out. And the CloudTrail, again, is not going to restrict anything. It's only going to monitor and tell you when something does happen. So this is correct, and then it's going to monitor and alert you to changes in policies, but again, it's not going to restrict anything, but that's kind of the requirement. So I'm going to go ahead and again select SCP here, and let's just go ahead and submit. I think that's like 10 more or less, but as you can see, there's 40 questions here. So again, if you want the rest of those, check out the link below in the description. So I'm going to submit. And then once you submit it, you're just going to say view score, and it will populate here. So, yep, this was correct. So Amazon S3 with encryption enabled for data at rest, along with logging and access controls, can meet the security requirements of HIPAA for the storage of protected health information, as long as it's used in a manner consistent with AWS guidance for handling PHI data. So we have a specific section here that does relate to HIPAA compliance from AWS, and you can check that out here. We don't need to dive too deep into this, but here it is. Okay. So yep, EFS is indeed that shared file storage that we're looking for. So it provides a simple, scalable, fully managed elastic file system. I always forget if EFS is for elastic file storage or system, whatever. I know it's file store for files. Judge me, I don't care. For use with AWS cloud services and on-premise resources, it's designed to deliver a high level of throughput and IOPS with the ability to burst to higher throughput levels for short periods of time to support the needs of the video processing tasks. That was a long sentence. Multiple EC2 instances can concurrently access an EFS file system, making it the best choice for this scenario. And in case you aren't sure what EFS is, Elastic File System, there it is. Here it is, and here is how it works. So again, you mount your file system to the mount points on your EC2 instances, and then that's what allows you to access the same file system from different instances. We've got a lab on this, so definitely check that out if you haven't already. So apply the principle of least privilege to IAM roles and enforce MFA. So kind of explain this when you're doing it, but least privilege, principle of least privilege says you only have enough access to do your job or some kind of function. And then enforcing MFA adds that extra layer of security to your AWS accounts and is recommended as a best practice. Okay. Of all choices, this is the best answer in regards to increasing security. So here is the principle of least privilege and a list of other security best practices if you want to go through here. Definitely important to get familiar with these, but as you can see, least privilege permissions here is one of them. And I believe MFA is also going to be in here. Yep, so require MFA, that is another one. All right. Moving on. So, yep, Snowball is going to be spot on for migrating from on-premise to the cloud, especially if you have a lot of data with slow internet. Okay, even if you had a fast internet connection, if you have enough data, you really want to consider using Snowball because it's going to be a shorter period of time to get your Snow family device, whether it's Snow Cone, Snowball, Snowmobile, whatever, upload it and send it back to AWS and have them upload it as opposed to trying to do all this over the internet. So you can check out more information about Snowball here and the rest of the Snow family as well. Okay. So, yep, right here. So, the reason why you would have these surprise charges for for RDS is because you paid to provision this the storage on this database. Even if you didn't use it, you still provisioned that storage. So if we come here and look at RDS pricing, we can see that, backup. So backup storage costs, you can see here, so there's no additional charge for backup storage up to however much throughput you have, or storage you have provisioned in a region. So if you've got an active MySQL database instance with 500 gigs and another Postgres instance with 200 gigs, you could have up to 700 gigs of backup storage for free, which is a huge amount of backup storage. So it's pretty nice. And then if you, let's see, so transferring data in, so data transfer cost. See here, so looks like we want to come here to see actual data transferring costs. So if we go to transfer cost down here, so data transfer between RDS, yep, free. So it's in here somewhere that so you're only it's related to EC2. My goodness, they're just making us jump through all sorts of links here to find the solution or the answer to one question. So data transfer between, so there's no charge for inbound data transfer across all services in all regions. Right, AWS wants your data, so there's no charge to bring things in, but of course there is charges to store and access and transfer that data back out. Okay. All right. So your organization operates, yeah, we don't need to read that. So yeah, using SCPs to deny the ability to launch those large EC2 instances except for certain departments is the way to go. So SCP is the right tool, and you can create an SCP that denies the EC2 run instances action for these specified instance types. So if we come here, we can see that there are some SCPs. And then you can look in here and explore the different policy types. You can even come over here and look at some strategies for using SCPs, some best practices. All right. So moving on. So so we want to use a VPC endpoint for S3 if we don't want to traverse the public internet in order to access a bucket. So if we come here, we can take a look at VPC endpoints. And again, for S3 and DynamoDB, you're going to be using gateway endpoints. Okay. Everything else, essentially, every other service is going to be using interface endpoints. Okay. So there's that. Amazon Aurora is a relational database service that does support read replicas, and then we can see more information about that here. So replication with Aurora, we've got Aurora replicas. Essentially, so these other deviances are read-only, and they're known as replicas. So they are read replicas, but AWS just calls them Aurora replicas, but just know that they're essentially just read replicas, okay? And okay, so what step functions? Let's go. I was actually thinking about that one. So step functions coordinates multiple AWS services into service workflows so you can build and update apps quickly. And we can look at more information about step functions here. Let's actually go to, so if we didn't get a question right, okay, what it would do is it's going to give you the correct answer here, and then it's going to give you the incorrect answers as well, and just explain, why they're wrong. And then it will also give you links again to the appropriate documentation. So for example here, it looks like we are looking to select the right type of EBS volume. So if you didn't select the appropriate type, you could just come here to EBS volume types and kind of compare what each one looks like and figure out its use case and what its features are. So yeah, that's a little bit of our Solutions Architect Associate Practice Quiz. You do need about 720 points to pass, similar to what you actually need on the test itself. So hopefully that's helpful. Again, if you want access to all of these quizzes, you can take them unlimited amounts of times. You get explanations for your right and your wrong answers. As you can see, you get links to documentation. Check those out in the description below. So hopefully this was helpful. If you've got your test coming up soon, best of luck to you. And we will see you next time.